NOT gate will produce the complement of whatever the input that it is taking. X plus y whole dash is equal to x dash into y dash. I can rewrite the equation or the expression as x plus y plus x dash y dash is equal to 1. Logic gates, I have two types of logic gates. One is basic gates, okay, another one is derived gates. Hello everyone, I welcome all of you to the fourth session on Boolean logics. My dear students, this session is going to be very important when compared to all other previous sessions of Boolean logic. If you ask me why, I will be discussing the important topic in this session, that is De Morgan's theorem. Even if you skip any of the topic in this chapter, but you should never take a chance to skip this De Morgan's theorem is what I would like to tell all of you with respect to the exam point of view. Alright, so without wasting much of your time, let me get into the session. What is that I have? So I have the recap. So in this recap, we all know that we have discussed different logic gates. So what is that we have discussed? We have discussed different logic gates. Along with this logic gates, we have also discussed how to write the logic gates or how to write the graphical symbol for a given expression in the previous sessions. Along with that, we have also understood how to write the truth table. This is what we have discussed in all the previous sessions. So fine, what is that I have now? All right, so let's check that. So this is the De Morgan's theorem. When I speak about De Morgan's theorem, we have two different De Morgan's theorem, that is first one and the second one. So basically, let me start with the first one. If you understand this, I think you will be able to understand everything in this chapter. So hope you have gone through the 7 different laws what we have discussed in the previous sessions. That is going to be very important with this. All right. So let's start. So what is that I have? So I have x plus y whole dash is equal to x dash into y dash. So let's write this. X plus y whole dash is equal to x dash into y dash. This is what I have. So I need to write the diagram for this. How do I write the diagram for this? Let's understand. Guys, I need to write x and y. So I have already written x and y. Let me change the pen color for all of you. So I have x and y. So obviously I need the OR operation. So fine, I have written the OR. So what will be the output? So I will get x plus y. So fine, what is that I need? I need x plus y whole dash. I need the complement of this. What is that I have to do? So I have to pass this output. I have to pass this output as an input for NOT gate. So please understand. So this R is equal to x plus y whole dash. This R is equal to x plus y whole dash. So fine, I'm done with this part. I need to write the graphical symbol for this part. So let's start writing this. So I have taken the x, okay, I have taken the y. But what is that I need? What is that I need? I need x dash. I need x dash. So for that reason, I am using the NOT gate here. Suppose if I pass the input as x, the NOT gate will produce x dash. So that's what you need to understand with respect to this part. Again, here I will be passing the y as an input for this NOT gate. So obviously, NOT gate will produce the complement of whatever the input that it is taking. Alright, so I'm passing the y as an input and it is producing y dash as the output. So fine, I got y dash, and x dash and y dash. So what does that I have to do now? I have to have x dash into y dash. So what is the gate that I have here? I have AND gate. So that's why I'm writing AND gate here. So that's what you need to understand. So this R is equal to x dash. So fine, we are done with the graphical symbols. We are done with the graphical symbols. How do we prove that? How do we prove that? So this x plus y dash is equal to x dash into y dash. Let's understand this. So first of all, to prove this, we need to understand or we need to remember a law called complementarity law. So we have, so p plus p dash is equal to 1. What is that we have? P plus p dash is equal to 1. The same way I have p dot p dash is equal to 0. According to this law, I'm rewriting this equation. How did you got this one? So this is what you're trying to prove, right? So how did you got this? So please understand, I had x plus y whole dash is equal to x dash y dash. So this is what I had. So according to this law, when I have x plus y whole dash is equal to x dash into y dash, I can rewrite the equation or the expression as x plus y plus x dash y dash is equal to 1. Along with that, I can also write x plus y into x dash y dash is equal to 0. So this is what I have to prove according to complementarity law. So fine. So you got to know that. So we need to prove this. I also told you how you got this. Let me explain that once again. So please understand. So let me explain that once again. So this is very, very important that you need to understand. How did I got this? Okay, how did I got this? This is very important that you need to understand. So fine. What is the expression that we have with respect to De Morgan's? So we have x dash y dash. So that's what we are trying to write it as x plus y whole dash. So x plus y whole dash is equal to x dash into y dash. This is the equation that I have. So fine. According to the complementarity law, so we are writing the expression something like this. So p plus p dash is equal to 1. P plus p dash is equal to 1. So p into p dash is equal to 0. This is the complementarity law. Okay. According to this law, I will rewrite my expression. What is that I have? What is the De Morgan's theorem that I have? So this is what I have. What is that I will do? So I will write x plus y. Okay, what is that I will write? X plus y. So after that, I will write plus x dash y dash should be equal to 1. X plus y plus x dash y dash should be equal to 1 according to this law. According to this law. That's what you need to remember. That's what you need to remember. In the same way, I will be proving this also. X plus y dot x dash y dash should be equal to 0. X dash y dash should be equal to 0. I am treating this as p and this as p dash. That's what you need to remember. Here, I am treating x plus y, this as p and this as p dash. That's what you need to remember. Sir, how are you treating this x plus y as p and x dash into y dash as p dash? So that's what you need to understand. So please understand, here I've written x plus y is equal to, what is that I have? X plus y dash is equal to x dash y dash. So based on this condition, I am treating this as p and p dash. That's what you need to understand here. All right. So fine. So you understood the logic, like, how did I arrive at this? So now it's time to prove. All right. Now it's time to prove. How do we prove this? So this is the equation that I have to prove. Okay. So let's start proving this. So please understand, what is the first thing that I have? X plus y plus x dash y dash is equal to 1. X dash y dash is equal to 1. So that's what I need to prove. All right, let's start with the first one. So before I start this one, you need to understand this law. What is that I have? I have distributive law. Okay, you need to know the distributive law. What is the distributive law? So x plus yz is equal to, so what is that I'm doing? So please understand, x plus y into x plus z. I'm just multiplying this. Okay, I'm just multiplying and I'm changing the sign. So here I have plus, so here I have into. All right, that's what you need to observe. So here I have into and I'm having a plus here. So whenever I multiply, I think you all know the distributive law. I don't have to explain this, but still easy to remember. So what is it I'm doing here? X plus y and x plus z is what I have. All right, based on this, let me solve this. How do we solve this? Let's understand. So what is that I have here? Please observe. What is that I have here? So this is what I'm treating it as x. All right. So what is that I have here? So please understand, x plus y plus x dash. X plus y plus x dash into x plus y plus y dash. So wherever I have plus, I will change it as into. So that's what you need to remember here. So fine. So you got this, you understood how did I got the statement. All right, so that is the formula. This is a reference that I'm using. So this is the law. Using this law, I have got this expression. So fine. After this, how are we solving this? So please observe. So whatever the x dash that I have, so I will write it this side. So x plus x dash. So you all know that x plus x dash can be written as 1. Okay, that's the law that we have seen in the previous sessions. X plus x dash can be written as 1. So fine. Here you need to observe that I have y plus y dash. Same way, when I can write x plus x dash, I can also write y plus y dash as 1. So fine, you understood that. So I will solve the next step, that is 1 plus y into x plus 1. So fine, you got to know that. So when you have 1 plus x or 1 plus y, so with reference to this, I will treat this as 1 and this also as 1. So 1 into 1 will be 1. Hence, it is proved. So this is the first thing that you have to remember. Let's come to the second one. If you understand the first one, the second one is very simple. So before getting into the second one, so please understand the reference. Okay, this is the law that we have to use. What is that we have? So x into yz is equal to xy into z. So that's what you need to remember. So what is that we are using, which law? So x into yz is equal to, so xy into z. So that's what we are trying to use. All right. So this is what we need to prove. So what is that we need to prove? We need to prove as 0. All right. Let's start that. What is the expression that we have? So x plus y plus x dash y dash. Okay. X plus y plus x dash y dash. So fine, we have that. So let's start now. So x dash y dash into x plus y. So this is the expression that I have. All right. So how do we do this? How do we solve this? So please observe here what I have. X dash y dash. Okay. X dash y dash into x. X dash y dash into x plus x dash y dash into y. So how did you got this? How did you got this? Please understand that. So please understand, here I'm multiplying. All right. Here I'm multiplying with this. Okay. X into x dash y dash. That's what I have written here. All right. So what is that I have written? X into x dash y dash. That's what I have written here. In the same way, y into x dash y dash. That's what I have written here. That's very simple. All right. You all know that. So according to this, so x into x dash. So I will rewrite it. This x, I will rewrite this side. So x into x dash will give you 0. Again you have y into y dash. It is 0. So multiplied by 0 into 0, it will give you 0. That's why I will end up with 0. Hope you understood. This is very simple. Right? So hope you are trying to understand. So this is very, very simple. This is the first De Morgan's law that we have. The reference is very, very important. This reference you should never forget. So that's why I told you in the previous session. So you should revise all the laws that we have given. I think I have given 8 to 9 laws. So please go back and check all the laws. This will be very useful. If you know that laws, it will be very easy to simplify it. Moving on to the next one. So I have De Morgan's theorem second law. All right. So let's prove this. Let's understand this. Again, it's very simple. What is that I have? So x into y whole dash and x plus y whole dash. That's what I have. So how do I write the diagram for this? So x, y whole dash. So what is the gate that I have to use here? What is the gate that I have to use here? I have to use AND gate. Okay. So fine. Let me just use x and y as an input. I have to use AND gate. So it will give me x into y. Okay. So I need to convert this to get this complement. So with the help of NOT gate. So fine. I got this. Then again, I have the second one. So x dash plus y dash. So fine, I'll take x and y. So, but I need to take x dash. So for that, I will be using the NOT gate here. So fine, you got the x dash. In the same way, you have the NOT gate and you will be getting the y dash for y. So fine, what is the gate that you have to use here? So since you have plus, so you will be using the OR gate. So you got it. So you understood the diagram. So we got the diagram. How to prove this? So let's start this. So let's understand how do we prove this. So guys, please look at this. I have xy plus x dash plus y dash. How do we have this? So how did we got this? So guys, I have x dot y whole dash is equal to x dash plus y dash. I'm using a complementarity law here also. So what is that? We are using complementarity law. So complementarity law in the sense like, p plus p dash is equal to 1, p into p dash is equal to 0. So the same thing I have to use here according to this law. So I am arriving at this. So what is that I have to prove? So guys, so please understand this. X into y plus, all right, x dash plus y dash is equal to 1 is what I have to prove. In the same way, all right, I have to prove x y into x dash plus y dash is equal to 0 is what I have to prove. All right. So I'm treating this as p and p dash, right? P plus p dash is equal to 1. Again, p into p dash is equal to 0. So this is what the comparison that you need to remember. All right. So based on this law, let me prove this. Okay. Let's start this. So I have the equation. So x into y plus x dash plus y dash. So with the reference of this commutative law, okay, hope you have seen that. Okay, x plus y is equal to y plus x is a commutative law. So based on this law, let me start solving this. All right. So I have written this. So you all know that based on the commutative law. So we have written this. I have just interchanged. All right. So there'll be no change. Even there'll be no, you'll not be having any changes even if you write like this. So you can write like this is what they are saying with reference to the commutative law. So fine. So what are the next step that we have? Before understanding the next step, we need to know the next law. I think you all know that this law, we have used this law in the previous theorem. So what is that? Distributive law. So x plus y z is equal to x plus y x plus z. All right. That's what you need to remember. X plus yz is equal to x plus y into x plus z is what you need to remember. This is very, very important. Based on this, we are trying to simplify this. All right. So what is that we are trying to do here? So please observe here. X dash plus y dash plus x. All right. X dash plus y dash plus x. What exactly? How exactly you are writing it? So let me show you this. All right. So how exactly you are writing this? So this is the equation. This is the law that you need to remember. So here, this is the x and this is the y. That's what you need to remember. X plus y. All right. X plus y. In the same way, treat this as x, and this is the next one. Okay. Here, what I'm taking is y, right? So treat this as y. That's what I'm taking here. So x plus y dash plus y is what you have to remember. So here I'm using this plus. Whatever I have this plus is what I'm treating this. Okay. This part, whatever I have, I'm treating this as x and this as y. So that's what you need to remember. All right. So again, I have this as x. Okay. And this as z. So this is what you need to understand. So if you take this, okay. So if you understand that, I think this will be very simple. So according to that distributive law, so what will I get? So x dash plus y dash plus x into x dash plus y dash plus y. That's what you need to remember. So fine. So you understood that. So you all know that in the previous slide, we have seen that x plus x dash is equal to 1, right? So based on that, so what I will do, I have x plus x dash plus y dash, right? So x plus x dash, what I have, I will make it as 1. So what I will get? 1 plus y dash. In the same way, I have x plus y dash. So y plus y dash, I'll make it as 1. So fine. What I will get? So x dash plus 1. So that's what I will get here. So I have got 1 plus y dash and I have got x dash plus 1. So how do I solve this? With the reference of this x plus x dash. So I have converted this. All right. So you all know that. So in the previous theorem I have shown you. All right. So please remember 1 plus x is equal to 1, right? So in the same way, with the same reference, all right, I will consider, okay, I will consider this with the same reference x plus x dash, okay. So I will come to a conclusion that, so 1 into 1 is 1. That's what you need to remember at this point of time, all right. So this is what you need to understand with respect to the LHS part. Let's start and prove this, okay, the second part. So please understand. So this is what I have: x into y into x dash plus y dash. All right. So this is what I have. I need to prove this as 0. All right. So how do we prove that? So for that, so you need to remember this. All right, this law, we are familiar with this law. So that is x into y plus z is equal to, so what is that I have? X into y plus x into z. So fine, we know this law. How do we write this? How do we convert according to this law? So I will multiply this. So xy into x dash. So that's what I have done here. So the result will be xy into x dash plus again xy, and I will multiply this with y dash. My answer will be xy into y dash. So fine, I got it. All right. So what will be the answer? X into x dash y. I will just rewrite this: x into y dash y. So, or you can also write x into y dash. That's what I have written here. So fine. The only intention is, if I get x into x dash together, it'll be very simple for me to simplify. So that's why I'm rearranging it. That's why that's a thing you need to remember here. So fine, you understood that. So you all know that x into x dash is 0. With the reference of x into x dash is 0, let me solve this. So x into x dash is 0, 0 into anything. Okay, so that I have, so 0 into y. So you will get 0. So again you have y into y dash, that is 0. So x into 0. That's what I have written. So 0 into 0 is 0. So that's why I have written 0 plus 0. So I have plus here. 0 plus 0. So 0 plus 0 will give you 0. So it is righteous. So hence it is proved. So this is the second theorem. Okay, this is the second De Morgan's theorem that you need to understand. So this first and second theorem is very simple. That is, you need to remember two important law. So the first one is complementarity law. Okay, so based on that, we are rewriting the first equations. All right. So if you have any doubts, so only if you know all the laws, only then you will find it easy. Otherwise you will find it very difficult. Even after my explanation, so you will find it difficult if you don't know that laws. So please go back to the previous session and watch and understand, write down that laws. Only then you will be able to understand this. Otherwise you will not understand this. All right. So if you know that laws, you don't want me, so it will be very easy for you to understand by yourself. So that's what you need to remember. So fine, moving on to the next one. I think I have discussed this. So very important thing is, like, I have some more gates. All right. So when I have logic gates, I have two types of logic gates. One is basic gates. Okay. Another one is derived gates. When I have basic gates, I think I have discussed about all the basic gates, that is AND gate, OR gate and NOT gate. So when it comes to derived gates, so with the help of basic gates, I will be deriving some of the gates. So in that, the first one that I have is NOR gate. So what is NOR gate? So basically, you will not do any changes. So you will write the OR gate symbol, but you will add the NOT symbol at the end. So this converts the OR into NOR. The complement of OR gate is nothing but NOR gate. So fine, let's understand this. So hope you understood the graphical symbol of this. How do we write the OR gate? So let's have two inputs, X and Y. All right. So I have the output as F. That's what you can write. All right. So instead of that, I have just written it as input A and input B and output Q is what I have written here. So since I have two inputs, I have four combinations of output. So you all know that if I have two inputs, 2 to the power of 2 is 4. That's why I have taken 4. So I have 0, 0, 1, 1, 0, 1, 0, 1. So that you all know. I don't have to speak again. How do I calculate this? So easy step I will tell you. So you forget this. All right. So let me just write down one more column for all of you. So 0 plus 0 is what? So you will write 0. Okay. 0 plus 1 is what? I'm performing OR operation. Please remember that. So 0 plus 1 is what? 1. So 1 plus 0 is 1. So 1 plus 1 is 1. So whatever I have here as my result, you just write the complement in the output. So if I have 0, I will write it as 1. If I have 1, I will write it as 0. If I have 1, I will write it as 0. If I have 1, write it as 0. So that will be the output for NOT gate. Whatever the output that I have with respect to OR, so complement it to get the output of NOR gate is what you need to remember. So fine, you understood the NOR gate. So what is the next one? I have NAND. It's very simple. Again, you will add the NOT symbol and you will complement the output of NAND gate. Is it? No, AND gate. So please remember that. So fine. You have again two inputs. Is it mandatory that you should have two inputs? Only two inputs? No, it's not mandatory. Minimum you should have two inputs. That's it. Maximum you can have a number of inputs. So that's a thing that you need to remember. So fine. So let's perform the AND operation here. So let's understand this. So 0 into 0 is 0. 0 into 1 is 0. Again, 1 into 0 is 0. So 1 into 1 is 1. So complement of this is what I will call it as a NAND. Okay. So I have 0, complement of that is 1. Again, I have 0, complement of that is 1. Again, I have 0, complement of that is 1. So again, 1 I have, complement of that is 0. This is what I will call it as a NAND gate. So again, I have NOT. So to convert the AND into NAND. So that's what you need to remember. So moving on to the XOR. So please understand this. This is what we call it as a exclusive OR. This is what we call it as a exclusive OR. So how do we write the graphical symbol for this? So please write the XOR. What is that I have? XOR. So what is the gate that you have here? So you have OR. So you will write the OR gate. All right. So this is what you will call it as OR gate, right? So imagine and understand. Okay. Beautiful OR gate. So how do I write XOR? So if you have one curve extra, okay, this is what you will call it as a XOR. This graphical symbol is what we will call it as a XOR. But the most important thing that you need to remember when it comes to XOR is, so how to write the truth table. So obviously I have two inputs. So for that two inputs, considering that I have written the truth table. So let me not discuss this 0, 0, 1, 1 and 0, 1, 0, 1. So this is what I have. So how to calculate the value here? So if you look at this table, if you look at this truth table, it might look it will be a little weird when we compare to all other previous tables, but there is a trick that you need to remember here. So please observe, I have 0, 0, output is 0, and I have 0, 1, output is 1, and I have 1, 0, output is 1 again. I have 1, 1, output is 0. What is the meaning of it? When you have odd number of ones, okay, your output will be 1. So that's what you need to remember. When you have odd number of ones, your output will be 1 is what you need to remember. How many ones you have? So no ones. So your output will be 0. So how many ones you have? You have 1, 1. So you will write it as 1 in the output. Again, same thing, 1, 1. So you will write it as 1 in the output. So here you have even number of ones. I have 2 ones. So that's why I will write it as 0. So this is what you need to remember. All right. So complement of this is XNOR gate. That's very simple. How do you write this? So you have XNOR. All right. Let's understand this. How to write the graphical symbol for this? So you should be able to write the graphical symbol by looking at the name. So what is the gate that you have? So you have OR gate. All right. So let me write the OR gate first. Then what is that? You have N. So N in the sense NOT. So you will write the NOT. So fine. After that you have X. So you'll write affix. All right. So this is what the XNOR. This is what we call it as a XNOR. So fine. Complement of that. Complement of XOR is XNOR. Right. There we used to calculate it for odd number of ones. Now you will calculate for even number of ones. So guys, so this will give you 1 again. So it's odd, so it is 0. So again it's odd, it's 0, even, so it's 1. So this is what you need to remember when it comes to XNOR. So guys, by this I have come to an end of the session. So this is what you need to understand for today's session. So guys, I have some more topics which I will be discussing in the coming class. That's going to be very important again. If you have learned something, so please don't forget to click on the like button. I'll say thank you for all of you.